Okay, hi guys. So I'm gonna finish. So in this part of the video, I am hoping that I finally finished the free response section of this final exam practice for college algebra. So the part that we left off in was the last part was part 4, and now we are in number 30, so hopefully if by this part we what is it called? We go ahead and finish this. Okay. So let's see. We're on number 30. It says, answer the following questions about the function f of x equals 2x squared minus x minus 1. Okay. So it wants to know, so the first one it says, it wants to know if negative 1, 2 is on the graph of f. So this is a parabola, obviously, and you don't have to graph it, but what you want to do is you want to plug negative 1 in for x. So you're going to do f of negative 1 equals 2 times negative 1 squared minus negative 1 minus 1. And then you're going to say that this is equal to 2 times 1 plus 1 minus 1. So this is equal to 2 plus 0, which is 2. So yes, because f of negative 1 equals 2. Alright, so it says, so part B says, if x equals negative 2, what is f of x? So again, you're going to want to go ahead and say f of negative 2. F of negative 2 equals, so you're going to do 2 times negative 2 squared minus negative 2 minus 1. This is equal to 2 times 4 plus 2 minus 1, which is 2 times 4 plus 1, which is 8 plus 1, which is 9. So f of negative 2 equals 9. Okay. List the x-intercepts, if any, on the graph. So we want to go ahead and set this equal to 0, because when it's talking about x-intercepts, you make y equals 0. And if we factor it, so 2 times negative 1 is negative 2. Then we have negative 1 right here. And then two numbers that multiply to negative 2 and add to negative 1 are negative 2 and 1. So then we do our box method because we have a is greater than 1. So it's 2x squared up here. The first number is negative 2x, so it's negative 2x, and then it's x, and then our c value is negative 1, right? So if you guys don't remember how it is, basically you do your ax squared term here, and then this is m, this is n, so mx, nx, and then our c value is, so basically here's our c value, which is the third term, right? Okay, so we have 2x and x, 1 and x, and then we have negative 1 and 1, right? So this factors to 2x plus 1 times x minus 1. So what you do is you say 2x plus 1 equals 0, x minus 1 equals 0, you solve for x. So subtract 1 on each side, you get negative 1 equals 2x, then divide by 2, and then you get x equals negative 1/2. Now, one thing I do want to like emphasize here is that when it's talking about x-intercepts, it wants the coordinate. It does not want, like, I mean, I don't really know how your professor or teacher would want it, but an x-intercept is always of the form like x comma 0, and a y-intercept is always of the form 0 comma y. So when it talks about x-intercepts, it wants it in coordinate form. So that means that if we have x equals 1 and x equals negative 1/2, so the x-intercepts would be negative 1/2, 0, and 1, 0, right? So these are your x-intercepts. And then it says, list the y-intercepts, if any, on the graph. So this is where the y-intercept is when you set x equal to 0, so 0 comma y, whatever it is. So you say f of 0 equals 2 times 0 squared minus 0 minus 1. This is f of 0 equals 0 minus 0 minus 1. This is f of 0 equals 0 minus 1. So it's f of 0 equals negative 1. So the y-intercept is 0, negative 1. Okay, it says answer the questions given the rational function g of x equals x over x squared minus 4. Okay, so this one, what you're gonna do is you're gonna go ahead and so the part that we can factor out, or the part that we can factor, is the bottom. So if we do g of x in factored form, we get g of x equals x, and then we do the difference of two squares pattern, which says that a squared minus b squared equals a plus b times a minus b, right? So that means that x squared minus 4 equals x squared minus 2 squared, which is equal to x plus 2 times x minus 2, right? So in factored form, this would be x plus 2 times x minus 2, and it says reduce if possible, but I don't see there being a nothing cancels with x, and there's nothing that cancels with x plus 2 or x minus 2. So this would be your answer here, okay? It says write the equation of all the asymptotes present on the graph of g of x. Okay, so for this one, I believe that because, so basically the asymptotes, so the vertical asymptotes would be x plus 2 equals 0 and x minus 2 equals 0. So if you subtract 2 on both sides, you get x equals negative 2, and if you add 2 on both sides here, you get x equals 2, right? So these are your two vertical asymptotes. So your vertical asymptotes are negative 2. So you want to make sure that you actually put the x equals negative 2 and x equals 2. You don't want to say negative 2 and 2 because they're not going to know what you're talking about. You always want to make sure you put x equals negative 2 and x equals 2, whatever number it is for x. And then for horizontal asymptotes, I believe there are no horizontal asymptotes for this one, unless I'm wrong. Maybe I'm wrong. I think I'm wrong, because I think it's y equals 0, if I'm correct. Because if you think about it, So if we look at for example, if we look at the equation y equals 1 over x, this is equal to x to the 0 over x to the first, where it's of the form y equals x to the m over x to the n, where m is less than n. And if you look at the graph of 1 over x, you would get that the horizontal asymptote is y equals 0, because you see how there's like a little, like, kind of like this. It doesn't cross this line here, right? So, if we think about it, we have x over x plus 2 times x minus 2, which means that if we look at the actual function, y equals x over x squared minus 4, if we look at this part here, this is y equals x to the 1 over x squared. And it would be the exact same thing. Like if we were to have x over x squared by themselves, it would be like 1 over x. And 1 over x has a horizontal asymptote of y equals 0. So here, the horizontal asymptote would be y equals 0. Okay. Like, you don't have to remember the rules for horizontal asymptotes as long as you remember how the graph looks and how different types of graphs look and what horizontal asymptotes they would have, just based on looking at the y equals part, or the line that they never cross, basically. Okay, so it's a stated domain of g of x. Okay, this one, so this one would be all real numbers. Now remember how I said you cannot, so basically the denominator cannot be equal to 0. So such that x plus 2 equals 0, or x plus 2 does not equal 0, and x minus 2 does not equal 0. This means that x does not equal negative 2, and x does not equal 2. Now, to go from, you want to draw a line, right? This is another way to do it. You want to put negative 2, and then you want to put, what else? You want to put negative 2, and then you want to put 2, right? So in reality, because they cannot equal negative 2 and 2, you're going to shade everything but those two parts. So like this, and then like this, and then like this, right? And then you're going to say, well, this is negative infinity, this is infinity, so it goes from negative infinity to negative 2, not including negative 2, right? And then union negative 2 to 2, and then union 2 to infinity, right? This is our domain. Okay, you want to make sure you put domain, like you don't want to just say the interval, but you want to say that that is the domain, because, well, yeah, I mean, I always, some teachers are like that. So I would put D and then this part, and then just put the intervals. Okay, this one says graph log base 2 of x and it says graph f of x equals log base 2 of x and g of x equals 2 to the x on the same coordinate grid, and clearly label which is which. And then it says also label at least 3 important points on the graph. you may change the scale on the grid if necessary. Okay. So give me 1 second, guys. Meanwhile, I connect my laptop here. This one, so you have to, one of the things that is very important to notice about these two equations is that, so if you think about it, when I said log base b of x equals y, if and only if b to the x equals y, or log base b of, my bad, log base, hold on, give me 1 second. Log base b of y equals x if and only if b to the x equals y. So, right, so, this means that they're inverses of each other, right? When we have y equals log base b of mx plus b, or anything, any equation really, I don't want to make it confusing, but any equation log base b of f of x where f of x is any equation. So basically they're inverses of each other, and an inverse means that, you know, that they reflect towards the x-axis. Now, what you're going to want to do is you're going to want to go ahead and graph 2 to the x. I would graph 2 to the x first, because that way, if you do 2 to the x, so y equals 2 to the x, if we do that first, it'll be a lot easier to graph this equation. That's just my opinion. I mean, you can do log base 2 of x, but if you don't know how it works, then you want to make sure that you convert log base 2 of x. Well, it's already converted for you, but basically graph the exponential first and then just use the rules of inverse functions to switch x and y. Okay, that's how I would do it, because in all reality, log functions are a little difficult to they're a little difficult to graph, at least for me. So it takes a little longer than exponential. So you're gonna want to say, so basically if we do an xy table and I say 2 to the x, right? I say 2 to the x, so let's do 2 to the negative 4. I'm going to go from negative 4 and then negative 3, negative 2, negative 1, 0, and then 1, 2. And of course, it's not going to go all the way. Probably only down to negative 1/8, from negative 1/8 to 4, since I can't really or actually maybe I can put 2 in terms of 2. Give me 1 second, guys. Okay, so maybe I can do it in terms of 2 instead. That way it flows more easily. Now, of course, so if we do 2 to the negative 4, for example, that's 1 over 2 to the 4th, which is 1 over 2 times 2 times 2 times 2, which is 1 over 4 times 4, which is 1 over 16. So this is 1 over 16. If I do to the negative 3, so just think about, if you think about 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, this is 16, 2 cubed is 8, 2 squared is 4, and 2 to the 1st is 2. Notice how, oh Lord, give me 1 second. Okay, so notice how, basically, notice how it's 2 cubed and then 2 to the 4th. So all you have to do when it's a negative exponent, you just have to flip it over. So to the negative 3, that would be 1/8. To the negative 2 would be 1/4. To the negative 1 would be 1/2. 2 to the 0 is always 1. 2 to the 1st is 2. 2 squared is 4. 2 cubed is 8. And then 2 to the 4th is 16. Okay, so even if, like, we do 2 to the 0, we can do it like that. And then 2 to the 1st is 2. And then 2 squared is 4. Right? And then 2 to the 4th is 16, which just goes off the grid. So really, it's going to be, like, off the grid. But the main idea is that it keeps getting closer and closer and closer to 0. So the equation would look something like this. Okay, and it doesn't have to be perfect, just as long as it's close. Okay, and obviously to do log base 2 of x, so one of the things is you have to know whether or not these two are inverses, right? Now, because it's 2 to the x, y equals 2 to the x, that means that in logarithmic form it would be, so give me 1 second, log base 2 of y would equal x. So basically log base 2 of x would be y, right? So they would be inverses of each other. So basically you would say, and you would just have to switch x and y, unless you want to go ahead and do log base 2 of x in an xy table, that's fine, but in my opinion, I don't think that that is the right way to go, because when you do, so for example, we already did the xy table here, all we have to now do is just say, well, obviously, we can switch x and y, so when x equals 1, y equals 0. When x equals 2, y equals 4, or excuse me, y equals 1. When x equals 4, y equals 2. When x equals 8, y equals 3. And when x equals 16, which is off the grid, but still, y equals 4, right? So we can plot those. 1, 0 is right here. 2, 1 is right here. 4, 2 is right here. 8, 3 is right here, and I'm sure that for x equals 6, or y equals 6 rather, we got, we have something like 2 point something, so it would, 6 would be kind of like right here, a little bit right there, right? And for y equals 0, or rather, for x equals 0, obviously it would be, so actually we wouldn't know what it would be, because honestly it would just go something like this, right? Since right here, like I said, it's a reflection, and you would do this, and any time that you have an inverse, you always have like a little reflection. And actually I drew it wrong. Hold on. Give me a second. It's like this. So like this. And this is the reflection across the x-axis. And this is how we know it's an inverse, because it is a reflection in the x-axis. You see how there's like, you know, there's a reflection in this point here, and then this point here, and then there's a reflection here, and then here, and then here, and then here. And the curve just has a whole reflection of itself, right? Across the x-axis, or across the line y equals x, excuse me. So are these two functions inverses? Yes, because they reflect across give me a second, guys. Oh my goodness. Okay, it says, are these two functions inverses? Yes or no? Explain. So, yes, because they reflect across the line y equals x. Okay, that's how we know they're inverses, right? Because they reflect across the line y equals x. Now it says here, it says solve the following equations. Okay, so I don't, let's see here what it says up here. Can't remember if it said no calculators allowed. I cannot remember. Okay, yes, no calculator allowed. Okay, so this one, so it says 2 to the x plus 1 equals 5 to the 1 minus 2x, right? So what you want to do is, since there is no way to actually do this by exponential equations, where we can say like 2 to the x equals 4, and then we have 2 squared equals 2 squared, so x equals 2, right? We can't do that here. So what you're going to have to do is you're going to have to say, and you can use either log or natural log. I like to use natural log, only because it's easier. So what I do is I say the ln of 2 to the x plus 1 equals the ln of 5 minus 2x, or ln of 5 give me a second, guys. So ln of 5 to the 1 minus 2x, and then you go ahead and you take so remember, ln of x to the n is equal to n, or rather, I'll say x to the b, because it's just easier that way. This is equal to b ln of x. Okay, so you have to use that rule. So basically you're going to say x plus 1, and you're going to put it in parentheses, times the ln of 2 equals, and then it's going to be 1 minus 2x times the ln of 5, right? Give me 1 second, guys. Okay, so so then we have x plus 1 ln of 2 equals ln of 5 times 1 minus 2x. So then we have, so this means that it's ln of 2 times x plus 1 equals ln of 5 times negative 2x plus 1, right? This is equal to x ln of 2 plus ln of 2 equals negative 2x ln of 5 plus ln of 5. So then you go ahead and you add 2x ln of 5 on both sides, right? And then you say, so then it's going to be x ln of 2 plus 2x ln of 5 plus ln of 2 equals ln of 5. So you go ahead and subtract ln of 2 on both sides, and you get x ln of 2 plus 2x natural log of 5. Ln and natural log are the same thing, by the way. Equals natural log of 5 minus the natural log of 2. And then you factor out the x, so x times the natural log of 2 plus 2 natural log of 5 equals the natural log of 5 minus the natural log of 2. So then it would be, you would go ahead and you would divide both sides by the natural log of 2 plus 2 natural log of 5, because basically it's being multiplied all the way, right? So then this part cancels out, and you do it on the other side as well. Ln of 2, natural log of 2 plus 2 natural log of 5, right? Oh gosh. Sorry guys, give me 1 second. Okay, so then you divide both sides by ln of 2 plus 2 natural log of 5, right? These two cancel out, so this all cancels out, right? All of this. You get x equals the natural log of 5 minus the natural log of 2 over the natural log of 5 plus 2 natural log of 5, right? And I don't believe that, so I don't believe that, you can actually factor that. I don't think so, because this is basically like saying, so it's negative ln of 2 plus ln of 5 over ln of 2 plus 2 ln of 5. Even if we were to factor anything out, we can't, because it's a 2 natural log of 5 on the bottom, so it wouldn't even cancel out at all. So you can write it either way. Oh, ln of, my bad, ln of 2 plus 2 natural log of 5, excuse me, plus 2 natural log of 5. So yeah, I don't think there's a way to actually factor this. Because, yeah, I mean, either way, it's either or. These are two ways. Okay, so two possible ways to write the answer is what it says. All right. 1/2 log base 3 of x equals 2 log base 3 of 2. Okay, the one way we can do this one is we can say log base 3 of x to the 1/2, because we can move this up here equals the log base 3 of 2 squared. Now, this means that x to the 1/2 equals 2 squared. And if you remember, if x to the m over n, so basically x to the m over n is going to be equal to the nth root of x raised to the m power, right? So that means that x to the 1/2 is the square root of x, and the square root of x equals 4. So then if we square both sides, we get x equals 16, and that is your answer. Oh boy, these ones are a little bit more difficult. Okay. All right, so let's see. I'm gonna try to look. So let me, because there are different equations to what is it called, to these kind of problems, and I don't want to mess up. These are a little tricky, I won't lie. These are a little tricky because when it comes to these problems, sometimes you can get very tricked and you can use the wrong what is it called? The wrong formula, right? Let's see here. Give me 1 second, guys. Okay, so this one, obviously, this one is, so I don't know what it is with this one, but obviously we're missing a lot of things here. I don't know why. So I'm just gonna go ahead and not do this one because it's missing a lot. There's some things missing here that we just don't know. There's supposed to be a function here, and we don't have that function. So we're gonna go ahead and do this one. It says given the function f of x equals x to the 4th minus 9x cubed plus 21x squared plus 12x minus 130. So it says to graph the function, and it says change the scale on the coordinate grid as necessary. So, I mean, obviously we can use a calculator on this problem. So if you have a calculator, I would graph it, since it says, I believe it says calculator allowed. Yes, calculator allowed. So if we graph it, x to the 4th minus 9x cubed plus 21x squared plus 12x minus 30 minus 130. So, okay, so how I'm going to do this is I'm just gonna go ahead and, because obviously, yeah, this is, it's a little bit, so the y-intercept is 130, obviously. Let's see here. I'm just trying to see exactly how I'm gonna go ahead and graph this, because, so maybe if I do by 100, negative 100, negative 110, negative 120, negative 130, and we know that at negative 130, that's the y-intercept, and I can do, I'm trying to think, because I don't know if I should do 1, 2, 3, and 4, given that, like, oh lord, this is really, tricky. So give me a second. I'm gonna try to do, okay, so if you use a graphing calculator, when x equals negative 1.5, y equals negative 129.5, which is really close to negative 130. When x equals negative 1, y equals negative 111. So it'd be like right here. And then when x is negative 1.5, y equals negative 65.3, so it'll be like probably right here. When x equals negative 2, y equals 18, so, oh, yeah, when x equals negative 2, let's see, hold on. Give me 1 second, guys. I'm trying to see exactly what, so, negative 1.5, and then it's negative 2. And x equals negative 2. Huh. Well, when x equals negative 2, y equals 18, so it goes like this, and then when x equals negative 3, it goes all the way up, so it's like off the grid. So basically, and then you would do kind of like a, so basically when x equals 0.5, y equals negative 119, so it'd be like right here. And then when x equals 1, y equals negative 105, so it'd be like right over here. And then when x equals 2, or rather 1.5, y equals negative 90, so it's like right over here. When x equals 2, y equals negative 78, so it's like even, actually, let me put it right here. When x equals 2, y equals negative 78, so it's like over here. So it looks kind of weird. Basically, because it's very zoomed in. It looks like this, and then it's like kind of like that. So it looks a little bit weird, but that's how it looks. Now it says to find the rational zeros that occur of f that occur. So basically, the rational zeros, if you look at the calculator, you have. So basically, if you look at the calculator, the rational zeros of f occur at x is approximately equal to 5.613, and x is approximately equal to negative 1.911. So these are the two, what is it called? The two, how do I say it? The two, intercepts. Now, for the, okay, so for the local, or for the local maximum and minimum values of f of x, basically, so let's see here. Local maximum and minimum. Okay, so obviously, the local maximum for this function is the one that is, how do I say it? It is the one that, is the first lowest value, right? So obviously, to find the local minimum, it would be, let's see here. Okay. So, you have to be careful with this one because, basically, this one, okay, so like for these two here, what I did, and I don't know if it muted it or not, but anyways, I just found the rational zeros of f where, with the graphing calculator, and then the local maximum and minimum values, I found them with the calculator. Now this third one, or this fourth one here, says so it says 1000x. So basically, they want us to find the remaining complex zeros, because remember that it really has 4 zeros. It has 4 zeros, but it doesn't mean that all of them are real numbers. That's why here we can't really see it, and there are no repeated roots on this one. So that's why the remaining 2 zeros that we need to find, we actually need to find them using some algebra and with polynomial long division. Now, these are the two equations that we have here, where we found our x equals negative, or x is approximately 5.613 and x is approximately negative 1.911, right? So basically, what you want to do here now is you want to go ahead and grab these two factors and multiply them. And of course, you can use a calculator to do this if you don't know, like, 1,000 times 1,000. That's why you have a graphing calculator to help you. So, like, 1,000 squared is 1,000,000 x squared. And then, so it'd be like this. You use FOIL method times, so it'd be 1,000 times negative 5.613. So it'd be minus 5.613, or sorry, minus 5,613 x, and then oh, actually, hold on. This should be, my bad. This is supposed to be 5,000, not 5 points. So basically it would be 5,613. So 1911. So basically you have 1,000 times 5,613, negative 5,613. That's negative 5 million. So it's minus 5,613,000 x, and then plus, and you would do 1911 times 8,000. So it'd be 1,911,000 x, and then plus, or rather minus, and then you do 1911 times negative 5,613, which is minus 10,726,443. Now, yes, this is a very large quantity. The one thing that the only problem, the issue with this problem is that they want us to find the remaining 2 zeros. This is a quadratic equation, okay? So basically you can now find these, or rather, so you can do you can do, you can solve this for x either using the quadratic formula or by graphing it, but basically we now have something like this, and so if we go ahead and add, so if we go ahead and add negative 5,613,000 and then 1,911,000, we're going to get negative 3 million, so it's going to be a million x squared minus 3,702,000 x minus 10,726,443. Yeah, this is a pretty rough one, and it wants us to find the remaining complex zeros that are in our equation. Give me a second. So basically, we have to divide this function. So we have to divide our original function by this function here. Okay. Now, obviously, it's not that easy. So it's a little bit complicated, but maybe we can use synthetic division, or I don't know if you guys learned synthetic division. We can use polynomial long division, x to the fourth, and then let's see here. Okay, so to do this one, oh lord, this one is crazy. This problem is a little crazy. I won't lie. So forgive me if I am making it a little more complicated. Forgive me. This is a very tough problem. So obviously we know two of our zeros, right? They want us to find the remaining two zeros. Now, so we can do this, and then it can go 1 over 1 million x squared times a million x, or it would be actually, yes, I'm right. It would be times a million x squared minus 3,302,000 x minus 10,726,443, and this would obviously be x squared, right? Oh, actually, hold on. This is x squared, my bad. So then it would be x to the fourth, obviously, and then you would do 3,302,000. So 3,302,000 over a million. That would be minus 1651 over 500x. And then you would do 10,726,443 divided by a million. So that would be, well, that would obviously just stay the way it is, minus 10,726,443. over a million x. Right. I mean, the other real option for this one is sorry guys, give me a second. Okay. The other real option for this one is synthetic division. However, I'm not 100% sure if they do synthetic division like in college algebra. I think they do, but yeah, this is a very difficult one. It is possible to do it. I'm not saying it's not. It's possible to do it. It's just a lot of work. So if I actually tried to solve this equation, maybe using the quadratic formula, then maybe that can help. But at the same time, they're very big numbers. They're very big numbers. I don't think that I don't think that it's really that easy to do this, because it's a very big like, they're very big numbers, is what I'm saying. Let's see here. Give me a second. So, because it's 1911 over 1,000. Negative 1911 over 1,000. And yes, 1911 over 1,000. And, I mean, in all reality, so, yeah, this one's pretty tough. I'm not gonna lie. It's a pretty tough one. I would say this is probably the only one that kind of stumbled me. I'm very close. I just need to know exactly how to, how to do this one, because I just don't really know. We're gonna go ahead and skip it, because, I mean, it's okay. I mean, obviously, you do not have to score 100 on, on the exam. It's okay, as long as you get a lot of them right. I mean, I'm not perfect. I definitely, despite me knowing a lot of things, I do have my weaknesses, and yes, this is one of them. Because obviously this is a very crazy one. Let's go to the next one. We're gonna go to the next one. So, okay. It says the marketing manager at Levi Strauss wishes to find a function that relates the demand D for men's jeans and P the price of the jeans. The following data were obtained based on a price history of the jeans. Okay. So this one, let me go ahead and, all right. So I can do a scatter plot of this, maybe using, so how much? 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, So I can do a scatter plot of this, and I'm assuming they're not asking for exact numbers, but they're wanting to at least kind of, know exactly, like, because of how much it would be counting by, because we have 1, 2, 3, 4, 5, 6, 7 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so, yeah, I mean, I'm just gonna go ahead and do however much, like, maybe I can do it by factors of, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes up to 30. Okay, so I can do it by factors of 3. So 3, 6, 9, 12, and then 15, 18, 21, 24, 27, and 30, right? And then over here, it goes from 44 to 60. So, given that it's 44 to 60, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, let's see here. It would be from 44 Okay, I'm just trying to see how I can split this graph up. I really hate that they don't give us like a labeled graph for how it should be. So if I just do so I'm gonna just go ahead and do this. So let's see, it's gonna be from 44 to 60. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So it's gonna be like not drawn to scale because I really just don't know how to split this. It's a little weird. Well, actually, we can actually use a graphing calculator for this. If you plug these numbers in on a table on your calculator, you can find the line of best fit by doing the what is it called? By doing whatever it asks you to do. So so yes, this I would recommend to use what is it called? The line of best fit, or your graphing calculator to do this one, because obviously, yeah, it's a little bit tricky. So give me 1 second, guys. I'm gonna go ahead and do all of this in the graphing calculator. Okay, so the way I'm gonna do this one, since I'm not sure exactly how they're doing it here, because we don't even have, like, they're asking us to draw a scatter plot, right? But the problem is that they're saying to change the scale as needed, so I don't think there has to be an actual, because let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so I don't think there actually has to be like an actual way to do this. So what I'm gonna do is I'm just gonna go ahead and do, so it's 20 and then 22 and then 23, or maybe I can skip some lines. The thing is, this one's a little tricky because, yeah, it's just not drawn to scale. I'm gonna say that it's not gonna be drawn to scale because obviously, and then it says the relation defined by the set of ordered pairs represent a function. It's no, because there's for one value of x, there are two different y's. Remember that a function is defined if and only if there is one y for every x, okay? So this is not a function. However, we can still do a scatter plot. Let's see. So I'm just gonna do it the way that I think it looks. So let's see, 44, and then we have 49, 57, or no, not 57, 52, 53, 56, 57, and 60. So, like I said, it's not drawn to scale. Actually, you know what? I'm just gonna go ahead and do it. Like, I'm not gonna do the whole graph. I'm not gonna try to fit it to the whole graph, because it's a little bit, this is just really complicated. So let's see here. Give me 1 second, guys. Okay, so let me just plot the points. There's 20, and 60, right? So 20, 60, and then it's 22, 57 right here, and then that's 23, 56, and 53, and then there's 27 and 52, and then 29 and 49, and then 30 and 44. And it's asking us to draw the line of best fit. So, I mean, oh lord. I mean, I honestly don't know how to do this part. But anyways, the data that models this function in reality is 1 point, so let's see, f of x equals negative 1.336 x plus 86.197. This is the function that best models this data. Now it's saying how many genes will be demanded if the price is $28 a pair. Now the price is the dollars, so if we plug in f of 28, we're gonna say negative 1.336 times 28 plus 86.197. So I will say it's about $48.79. Or actually, hold on, no. How many genes will be demanded? Okay, so it'll be about 49 genes, because you want to do it in a whole number. Okay, so it says use your calculator to solve the following equation for x. So you're just gonna graph this function in reality, and you're gonna graph this function, and then you're gonna look for the roots. So 22x squared, or 24x squared, excuse me. Let me go ahead and graph it. Okay, so then you do the graph entry edit, and then you go to this is if you have TI Inspire. But anyways, you go to graph entry edit, and then you do for the zeros, so it's x equals, and for the first one it would be, so let's see for this one really quick. So the first one would be negative 8.680, and then x equals 0.389. These are your two roots. And then, and now it's asking us to evaluate the following and round it to 4 decimal places. Log base 3 of 52. So you're just going to go ahead and use your calculator for that. And it says, okay, so this is what it equals to, and then it says approximately, so basically that in 4 decimal places, excuse me, is approximately equal to 3.5966. Okay. Okay, it says write an equation of one possible polynomial which has the x-intercepts x equals -3, x equals 4, and x equals -1, and x equals 0. Also, the degree of the polynomial is 10, and it is known that the graph crosses the x-axis at x equals -3 and touches the x-axis at x equals 4 and x equals 0. Oh my. So let's do this step by step. It's saying, basically, so you have one possible polynomial which has x-intercepts at x equals -3. So obviously, we have x plus 3, the roots are x plus 3, x equals -3, so the factors are x plus 3, x minus 4, and x plus 1. And I say that because when you set this equal to 0, you get x equals -3, etc. You set all these equal to 0, you get these answers. And then you have x equals 0, so times x as well. And it says that the degree of this polynomial is 10, and it is known that the graph crosses the x-axis at x equals -3 and touches the x-axis at x equals 4 and x equals 0. So obviously, we already know that. However, there's a difference so basically, it's saying that it crosses the x-axis. When it's saying crosses the x-axis, this is what it means. Any polynomial that you have, when it crosses the x-axis, it's actually going through. Now, there's a difference between that and the fact that it touches the x-axis. When it's saying that it's touching the x-axis, so here it says it crosses the x-axis at x equals -3. So obviously it'll be like, so this is -3, it's gonna go like this, and then it's saying touches the x-axis at x equals 4, so like this, and then at x equals 0, which would be something like this. Now, it does not tell us whether or not this polynomial is positive or negative. It doesn't tell us that, but it does tell us, it doesn't tell us whether or not it is positive or negative, but it does tell us that these are the degrees, that it's of degree 10, and that it touches these axes here, these points. Now, it's saying that it touches the x-axis at x equals 4, and this is 0. So obviously, if we have any polynomial where you have something like this is obviously a repeated root at x equals c, at x equals a constant c. Now, obviously, because this is a polynomial, so basically it's a polynomial of degree 10, and it's saying that it touches the x-axis at x equals 4 and x equals 0, and it crosses the x-axis at x equals -3. So we can say that this is x plus 3, and then because it is of degree 10, and it touches, there are 2 repeated roots, and it has to be of degree 10, then that means that x minus 4, so basically we have x plus 3 to the first, and then x minus 4, we can say that this is, basically we can say, oh, and they also say that x is also a repeated root. So let's see here. This is a little tricky, I'm not gonna lie. It's a little bit tricky, so give me 1 second. Okay, so this one is very interesting. Now, it says that it goes through x equals -3 and x equals -1. So x plus 3 times x minus 1, those are 2 factors. Now, it also says that it touches the x-axis at x equals 4 and x equals 0. So because these two, specifically these two, give off a degree of 2, then that means that the remaining two powers of these 2 factors they have to both equal 10, right? So, or actually, hold on. It would be x to the 1, so it's x plus 3 to the 1 times x plus 1 to the first power. This is a degree of 2, so then we need 8 more degrees to get to a degree of 10, right? So it's gonna, so the 2 numbers that I can think of are 4 and 4. So it would be, so the polynomial would be x plus 3 times x plus 1 times x to the 4th times x minus 4 raised to the 4th power. So this is f of x equals, and this is how you would do it. This one's a little bit tricky, because you have to know what it means when it's saying it touches the x-axis versus crosses the x-axis. When it crosses the x-axis, it literally goes through it. When it touches it, it's like this. It just touches the x-axis and keeps going. So you have to be careful with that one. Okay, I believe this is the last one. So this one says, write the equation of a quadratic which has a vertex of 6, -4, and goes through the point 2, -5. So this is like an example that we've done before. So we would say y equals a times x minus h squared plus k, right? So then we have, so it's -5 equals a times, and the x value is 2, And the vertex is hk, so the vertex would be, so h is 6, and then the k value is -4. So basically we have -5 equals a times the quantity 2 minus 6 quantity squared minus 4, and you would say -5 equals a times -4 squared minus 4. This is -5 equals 16a minus 4. So you would add 4 on both sides, you get -1 equals 16a. You divide both sides by 16, you get a equals -1 over 16. So your equation would be y equals -1 over 16 times the quantity x minus 6 squared minus 4. Okay. And this is your final answer. Okay, guys. So that concludes, finally, concludes this review. So, like I said, it was, hopefully my videos helped a lot. If you are still confused on things that you're wondering about or things that you're confused about in this class, like, I do have videos on that. And I only skipped maybe 1 or 2 of these because it's just really difficult. But for the most part, I would say I did a good job. Like I said, I hope this helps. And now that, now that I've already gone through algebra, I think I can go ahead and go over more of, I guess, a little more with pre-calculus, specifically on like a very brief level, like with algebra very briefly, and then move on to vectors and sequences and series and, all the other fun stuff. So with that being said, I wish everybody luck on their final, and I hope this helps, and I will see you guys in the next video. Bye, guys.